Hi everyone, welcome to Raaonline. This is Dr. Priyadarshini Shanmugam, Professor of Microbiology, and today I am going to discuss about the mechanism of action of antibiotics and the mechanism of drug resistance. And the learning objectives for today's session will be: what is the definition of antimicrobial agent and an antibiotic, how you classify the antimicrobial agents and the antibiotics, the mechanism of action of various classes of antibiotics, then the mechanism of drug resistance, by which bacteria develop resistance to these antibiotics, and names of a few common drug resistant organisms with the mechanism of resistance. And regarding the definition of antibiotics and antimicrobials, so first of all, antimicrobials are agents that kill or they inhibit the growth of microorganisms. And antimicrobial agents can be classified, one, according to the microorganisms against which they are used. For example, antibacterial means they act against bacteria, and so on for antifungal, antiparasitic and antiviral agents. According to the ability to whether they are able to kill the organism or whether they are able to inhibit the growth of organism, they are called as cidal or static. So the suffix will be cidal, which means killing, or static, which means inhibiting the growth of the organism. So for example, when you say bactericidal, it means that they kill the bacteria, and bacteriostatic, which means they are just inhibiting the growth of the bacteria. And another classification of antimicrobial agents is as per the source. When you say antibiotic, antibiotics are natural substances which are produced by other microorganisms, which will be either inhibiting the growth or which can kill the other microorganisms. Whereas when you say chemotherapeutic agents, they are chemically synthesized in the labs, and they also have the antimicrobial properties. So we just saw what are antimicrobial agents and how they are classified, okay, based on either against which microorganism they are used, based on whether they are able to kill or just inhibit the growth of the organism, and according to the source of these antimicrobial agents. Now we come on to antibiotics. Antibiotics are specifically used against bacteria, and they are biological substances which are naturally produced by some microorganisms. And these antibiotics, again, they can either kill, where they are known as bactericidal, or inhibit the growth of other bacteria, where they are known as bacteriostatic agents. And now coming to the classification of antibiotics, based on which part of the bacterial cell the antibiotic acts, you have different types of actions. They are classified as, first one, the most common group is cell wall synthesis inhibitors. In this we have common penicillins, then we have cephalosporins, monobactams, carbapenems, then we have cycloserine and vancomycin and bacitracin. So why I told penicillin first is, this was the first antibiotic to be discovered, and then following it all the other antibiotics came. So the cell wall synthesis inhibitors are a very important and a very commonly used group of antibiotics. Then there are other group of antibiotics which act on the enzyme DNA gyrase. So they inhibit the enzyme DNA gyrase which is there in the bacterial cell, thereby prevents the replication of the nucleic acid. This group of antibiotics are mainly quinolones, and examples for quinolones will be nalidixic acid, ciprofloxacin, and you have another antibiotic known as novobicin. Then there are some antibiotics which prevent the elongation of the RNA, and that is actinomycin. Then there are antibiotics which act on the DNA directed RNA polymerase, and that is rifampin and streptoviricin. This rifampicin is a very commonly used drug for anti-tubercular therapy. Another important group of antibiotics are those which inhibit the bacterial protein synthesis, and this we have two categories: 50S ribosome inhibitor and 30S ribosomes inhibitor. So they inhibit the ribosomes, so they prevent the synthesis of protein within the bacteria. Okay, and most of these protein synthesis inhibitors are bacteriostatic, with a few exceptions which I will be just discussing later. So 50S ribosome inhibitor is erythromycin, common one. Chloramphenicol, it is no longer used so commonly because it is a very toxic drug. Clindamycin and lincomycin. 30S inhibitors, still we have heard about tetracyclines, spectinomycin, streptomycin, gentamicin, amikacin and nitrofurans. All these are 30S ribosome inhibitors. Then the tRNA, that is the transfer RNA inhibitors, which also by acting on this tRNA, they can also inhibit the protein synthesis. This is mupirocin, which is a topically applied ointment, and puromycin. And then coming to the cytoplasmic membrane, the structure of the cytoplasmic membrane can be disrupted by certain antibiotics like polymyxins and daptomycin. And then there is another metabolism which is going on within the bacteria, which is the folic acid metabolism. And they have antibiotics known as trimethoprim and as sulfonamides. And both of these antibiotics will be acting on this folic acid metabolism. So once the metabolism inside the bacteria is stopped, then the bacterial metabolism is only important for all the other activities. So the activity gets suppressed. So this is the main classification of the antibiotics based on the site on the bacteria in which they act. So now we will be going on to the cell wall synthesis inhibitors. So in the cell wall synthesis inhibitors, we have a common group of antibiotics known as beta-lactam antibiotics. All these antibiotics have a ring which is known as the beta-lactam ring. And the cell wall synthesis inhibitors, these antibiotics are always bactericidal. So how they do it is they block the peptidoglycan. We already saw in morphology of the bacterial cell wall where the peptidoglycan plays a very important role in giving the structural integrity to the cell wall. And the synthesis of peptidoglycan is blocked by these antibiotics. So as a result of which the cell dies, the bacterial cell dies. So in the beta-lactam antibiotics, we have a very important group known as the penicillins. As I told earlier, they are the first group of antibiotics to be discovered. And in penicillins, you have certain developments and upgradations. So the commonly used or the first one to be discovered was just penicillin. In that you have different types: penicillin G, aqueous penicillin G, procaine penicillin G, benzathine penicillin and penicillin V. And just know that most of the penicillins are very effective only against the gram-positive bacteria. So you have the cocci, the Streptococcus pyogenes, Pneumococcus, the gram-positive bacilli such as Corynebacterium diphtheriae, Clostridium tetani and perfringens. And then you have 2 gram-negative bacteria also. They are gram-negative cocci, meningococci and gonococci. And then the spirochete, Treponema pallidum and of course Leptospira. So penicillins are very effective against these gram-positive organisms.